Welcome to the answers to quest number 1 that we did today, 27th of January 2015. Here it is. First question gives you the conversions. 1 meter is 100 centimeter, 1 inch is 2.54 centimeter, and 1 feet is 12 inches. And you're asked to find how many feet cube would you have in 1.5 meter cube. First, let's find out how many feet are there in 1 meter, for which 1 meter is 100 centimeters. So if you divide 100 by 2.54, you will get the number of inches. Does that make sense? You get the number of inches in 1 meter, because 1 meter is 100 centimeters. And then you have 2.54 centimeters in 1 inch, and you divide that to get the number of inches in 1 meter, and that it turns out to be 39.37 inches per meter. And then, because you know there is 12 inches in a feet, you divide 39.37 by 12. You get 3.28 feet in a meter. Okay, so 1 meter is that. Now, to change 1.5 meter cube into feet cube, you would have to multiply by 3.28 3 times. Okay, because it's a cube, and that's why I've raised it to 3. And when you do that, you will get 53 feet cube. And okay, I seem to have missed the second question. That's fine. Now this question talks about a car accelerating from 5 meters per second to 21 meters per second at a rate of 3 meters per second squared. So you have the initial velocity, you have the final velocity, and you also have the acceleration. And you're asked to find the displacement. So delta x is unknown. Got to remember the equation that connects these 4. So those are the 4 quantities. And substitute the numbers. (21 squared is 441, 5 squared is 25, and you get 6 delta x. Simplify that, so it's 441 minus 25 divided by 6, of course. And the answer comes out to be 69 meter. In the third one, it's an 8.7 hour trip, which is made at an average speed of 73 kilometers per hour. The first third of the trip, and it says chronologically, means it takes 1/3 of the time. For the first part, it takes 1/3 of the time. Let me draw the picture. So that's the 3 parts, and it's talking about time. So the time taken for the part AB is 8.7 divided by 3. Time for AB is 8.7 by 3, which is 2.9 hours. And then the displacement AB is just the speed, which is 73 kilometers per hour. Oh, wait, hold on. It is 96.5 kilometers per hour, sorry, multiplied by 2.9. And you get the displacement AB. Now the total displacement is the average speed for the whole journey, which is 73 kilometers per hour times 8.7. So you get the total displacement, AD. So now you could find out the displacement BD. subtracting 635.1 minus 279.9. And if you divide that by the time, you will get the average velocity. Okay? Because average velocity is total displacement divided by time, which gives you 355.2 by 5.8, which comes out to be 61 kilometers per hour. And in this question, a car is traveling north at 17.7 meters per second. After 12 seconds, its velocity is 14.1 in the same direction. Find the magnitude and direction of the car's average acceleration. Okay, you notice that it's slowing down because its initial velocity was 17.7, but the final velocity is 14.1. Since it's slowing down, although it's going to the north, the acceleration is going to be to the south. Okay? The acceleration is going to be to the south. And then the initial velocity is 17.7. The final velocity is 14.1. The time taken for that change is 12 seconds. And you can find the acceleration just by taking the difference between the velocities and dividing it by the time. And that gives 14.1 minus 17.7 divided by 12. That comes out to be negative because it's slowing down. So it's minus 0.3 meter per second squared, or it's plus 0.3 meter per second squared to the south. So remember that negative there, it shows that the acceleration is opposite to the direction in which the car is actually moving. The sixth one, a ball is thrown straight up with a velocity of 39 meters per second. How much time passes before the ball strikes the ground? In this case, the ball goes straight up and comes back to the same point where it started from, so the displacement is 0. That's important. The initial velocity is 39, but the displacement is 0. And initially it's going up, and you only consider what's happening in the beginning, so it's slowing down. It's negative 9.8 meters per second squared, and you got to find the time. Now the equation that relates these four terms is this one. Delta x is VIT plus 1/2 AT squared. Now carefully just put the numbers in and do your algebra, and you will get the answer. Now take one of the terms to the other side, and both become positive and cancel the t squared. So 1t goes off from both sides, and and then you get t as 39 by 4.9, which is 8.0 seconds. Brings us to the seventh one. A test rocket is fired straight up from rest, so the initial velocity is 0. The acceleration is 20 meters per second squared. And after 4 seconds, the motor turns off, but the rocket continues to coast upward. What maximum elevation does the rocket reach? So there are two parts in this journey of the rocket. During the part AB, it has an acceleration of 20 meters per second squared. But at B, when the motor turns off, it becomes a freely falling object. So that means the acceleration during this part is minus 9.8 meters per second squared. So there are two parts. Alright, so let's look at the first one. AB, the initial velocity is 0. The final velocity, we do not know. We're going to find out. That would be the velocity at B, right? The final velocity. And acceleration is 20. And time is 4 seconds. So we can use the equation VF is equal to VI plus AT. And calculate that. That comes out to be 80 meter per second, right? 20 times 4. Now that would be the velocity at B. Now that is the final velocity at B, and when you consider the part BC, that's going to be the initial velocity. All right, that's going to be the initial velocity there. Okay. And final velocity is 0, of course. So VI is 80 meter per second, and at C velocity is 0. So final velocity is 0 there. You're asked to find how much higher it will go. So delta x, and acceleration is minus 9.8 meter per second squared. Again, use the equation Vf squared is equal to Vi squared plus 2Ax. And calculate x. And that's going to be 6400 divided by 19.6 when you switch both sides. Okay, that possibly got hidden under smart physics, but the answer, because you cannot see it, is 327 meter. 327 meter there. And then you have the, you have to continue, because you're, let's go back and see, x is 327 meter. See, that is just the displacement for the part BC. And the question actually wants us to find the total height from the ground. So next what we need to do is find the displacement AB. For the part AB, we know the initial velocity, we know the final, we know the time taken. So this is what we're going to do. Use the formula VIT plus 1/2 AT squared. And the first part becomes 0, of course. Second part is 1/2 times acceleration was 20, and it was for 4 seconds, and 4 squared is 16. So when you do all that, you get 160 meter. Now if you add the two displacements, you will get the total displacement. And that is 327 plus 160, which gives 487 meter. Okay, brings us to the 8th question. An airplane needs to reach a velocity of 203 kilometers per hour to take off. Now, see that the velocity is in kilometers per hour. You need to change it into meter per second. And to change that in a meter per second, you multiply by 1,000, because 1,000 meters is 1 kilometer, and 1 hour is 3,600 seconds. Okay, so you divide by that, you get 56.38 meter per second. That's the initial velocity. No, I'm sorry, that's the final velocity. Oh, pardon me, because the plane needs to reach that velocity to take off. The initial velocity is 0, and then it's a 2,000 meter runway, so delta x is 2,000, and you have to find A. The equation that has these 4 terms, we've used that equation a couple of times already. Plug the numbers into that, make acceleration the subject, and then you get the acceleration as 0.79 meter per second squared. That's the answer. And that brings us to question number 9. Assuming equal rates of acceleration in both cases, how much further would you travel if braking from 56 miles per hour to rest than from 28 miles per hour? Now this is simply a ratio question, because if you're driving at 56 miles per hour and you want to come to a stop, you're going to drive much more. You're going to move much more. But how much more would you move is given by the equation Vf squared is equal to Vi squared plus 2a delta x. Now we're looking for displacement, so if you look at this equation and make delta x the subject, this is what you get. And then the final velocity is 0, the acceleration is the same because the question says assuming equal rate of acceleration. So now we just look at the displacement and the initial velocity, and you see that it is proportional to the square of the initial velocity. So in this question, the initial velocity 56 is double 28 and 2 squared is 4. So if you're driving at 56, you're going to have to move 4 times greater distance as compared to when you're driving at 28 miles per hour, and I'm sure that makes a lot of sense. So it's 4 times further. It brings us to the last question. Acceleration is sometimes expressed in multiples of g, and where g is the acceleration due to the Earth's gravity. In a car crash, the car's velocity may go from 26 meters per second to 0 in 0.15 seconds. So that's a small time, which means the acceleration is going to be huge, or rather the deceleration. So first let's find out the deceleration. The initial velocity is 26 meters per second. The final is 0 there, and the time is 0.15 seconds. And we could find the acceleration. To find the acceleration, we have to use Vf minus Vi by t, and that gives 0 minus 26 by 0.15. You get 173.3 meter per second squared. Okay. Now, how many g's is that? To find that, you just divide that by 9.8. And you get 18g. And if you heard somebody sneeze in the background, that was my wife. Poor thing, she's suffering. Okay. Anyway, I hope you understood all these problems. Thank you and good luck.